Hi, my name is Hiba, and in this video, I'm going to explain how I found the equations for each segment of my BMX race route and how I determined the domain and range for each one. So before I look at the graph, I'm first going to look at this chart right here, which is going to tell me the 5 different functions to use for each segment. So my track is made of 5 different functions, and the graph is right over here. So I'm going to be determining each one of the points, each one of the segments, using these 5 different functions. So for my segment AB, I'm going to be using a quadratic and vertex form. For segment BC, it's going to be for segment BC, I'm going to be using a sine function. For segment CD, I'm going to be using a square root function. For segment DE, I'm going to be using an exponential function. And for segment E, I'm going to be using a cosine function. Okay, so I'll go through each segment one by one, explaining my thinking and the steps I used. Okay, so for segment AB, I'm going to be using a quadratic function, as I mentioned earlier. So from the graph, I know that the path starts at 0, 22, and it ends at 6, 16. So, and the lowest point of this curve is the vertex, which is 4, 14. So because I know my vertex, I'm going to be using the vertex form of a quadratic. So which is y equals to ax minus h squared plus k. Now that I have my quadratic function down, now I'm going to be substituting in a couple values. So here, first I'm going to be substituting the vertex. Since I know that, I can easily just substitute that for h and k. So if I'm just going to write that down. So 4, 14. So 4 is going to be my h, and 14 is going to be my k. So now I'm just going to be simply just substituting those values in. A x minus 4 squared plus 14. Alright, so now that I have substituted that in, now I need to find the value of a. To do that, I use one of the points in the curve. For example, I'm going to use point A, which is 0 and 22. So I'm just going to write that down. 22 point A point 4. Okay, so using those, I can determine the value of a. So 0 is going to be used for x, and 22 is going to be used for y. Okay, so if I were to substitute that in, that would be a 0 minus 4 squared plus 14. Okay, now I'm just going to quickly solve this. So that's going to be 22, and then square root that. So that's going to be 16. So I'm going to get 16 over here, and plus 14. And then bring this 14 on this side. So that's going to be a 8, 16, a. So 16, 16, and 0.5. So that's a. So my a is 0.5. So my final equation for segment AB is going to be y equals to 0.5. Y equals to 0.5. X minus, no, sorry. Y equals to 0.5. X minus 4 squared plus 14. Okay, so that's how I solved for segment AB. Now I'm going to find the domain and the range. So to find the domain, I look at the x values where this segment starts and ends on the graph. So looking at the graph, it starts at, so the starting x point is 0, which is for point A, so I could just write that down. So for my domain, it starts at x equals to 0, which is for point A, and then it ends, if I look here, so B is my ending point, it ends at 6, which is for point B. X equals to 6, which is for point B. So the domain is going to be, that's going to be domain. And to find the range, I look at the lowest and the highest y values on the segment. So the lowest y value is at the vertex, actually, and it's 14, and the highest one among these points is 22, which is for point A. So for the range, it's going to be the lowest point. The lowest point is the vertex at y equals to 14, And the highest point is at A, where y equals to 22. So my range is going to be 14, 22. Okay, so that's going to be my domain, and that's going to be my range. And this is how I solved for segment AB. Okay. Next, I'm going to be finding for segment BC, which is modeled by a sine function. If I look at this chart right here, so for segment BC, it is a sine function. So that means, first I'm going to look at the graph and collect all the information. So from the graph, I know that it starts at B, which is 616, and then it has a peak over here, which is 717, and then it has a valley over here, which is 915, and then it ends right here, which is C, and then that is 1216. So what I'm going to do is that first I'm going to find the midline and the amplitude. But before that, I'm just quickly going to write down all my values. So B, I have 616, and then the peak is 717. It has a valley over here, which is 915. Oh, it has a valley over here, actually. That's the peak, and this is the valley. And then for C, it ends C, which is 1216. Okay, so those are my points. And first I'm going to find the midline and the amplitude. So the midline, first I'm going to explain what that means. So the midline is the average of the maximum and minimum y values. So the midline is the average of the maximum and the minimum y values. So that means that I'm going to be adding the maximum and the minimum y values from the points I have. And then I'm going to be dividing it by 2, and that's going to give me my midline. So first I'm just going to write it down. So my maximum and my minimum value. So now if I look over here, my maximum, my highest y value among all of these is 17. So 17 is going to go here. And my minimum, the smallest y value, or the least y value, is going to be 15. So 17 plus 5, and then divided by 2. And that's going to give me 16. Okay, so that's my midline. And then, so this means the sine wave oscillates around y equals to 16. Okay, so now I'm going to find the amplitude, and I'm also going to write down what it means. So the amplitude is the half. The amplitude is it's a half distance. So actually I wrote it wrong. So the amplitude is half the distance between the maximum and minimum value. Okay, so the maximum and the minimum value. So that means this time I'm going to be subtracting these two because I'm finding the half distance. So that's going to be 17 minus 15 and then divided by 2. So I'm also going to write it down like that. Okay, and then now I'm just going to be subtracting that and dividing by 2. It's 2. So that is 2. So I'm going to get 1. So that means the sine function has the amplitude of 1. Next, I'm going to be finding the period from the midline. So if I look over here, so from the midline going up to the peak, so x equals to 6, x equals to 7, is actually 1/4 of a full sine cycle. So that means for the period, that I'm going to be multiplying it by 4 because it's a quarter. So that means it equals to 4 times 7 minus 6. And I'm going to solve. So 4 times 1 is just 4. So that is my period. Okay, so next I will be finding the frequency, which is also abbreviated for K. So the frequency K is going to be K equals to 2 pi over the period, which we have right here. So that is the formula actually for the frequency to find that. That's going to be giving me the K value, and the period's going to help me find the K value. So that means 2 pi period 4. And then now I'm just going to do simple math, and that's going to be k equals to pi over 2. Okay, so I'm going to write it down here. So k equals to pi over 2. Okay, so that's my frequency. And then I will be looking at the phase shift. So I'm going to start that in a different paper because I don't have room. So continuing BC over here in this paper. Now I'm going to be finding the phase shift. So if I look at the graph, x equals to 6 is on the midline and going upward, which is exactly how a standard sine function starts. So the horizontal shift is 6. So that's my horizontal shift, which is 6. And then if I'm going to put all of this all together, this is what my sine function will look like. So collect the frequency, which is going to be pi over 2. And I'm going to bracket this to separate the sign. And then x minus 6. And then bracket plus 16. Okay, which was my midline. So I just basically collected all my information and put it in the sine function. So this is what I'm going to get. So now I'm going to find the domain and range for BC. So for the domain, I look at the x values where the segment exists. So it starts at 6. So starts at 6 and ends at x equals 2. And I forgot to write the x equals 2. And ends at x equals 2, 12, which is a C. So that's going to be 12. So that means, just like how I did for segment AB, x and 12. And next I'm going to find the range, which was the lowest and the highest y values. So for the range, I use the lowest and the highest values. So the minimum y value was my valley. So that's going to be the y value, which is the value. It's right here, the 15. That was my lowest y value. So that's 15. And then my maximum y value, which was the peak, which was the highest one, and that's 17. So that's 17. Okay, so that's going to be 15 x 17. So this is how I found for segment BC. This is how I solved for it. So I listed all my points, and then I find the midline, and then I find the amplitude, then I found the period, then I found the period to help me find the frequency, and then I found the phase shift. And the phase shift was just my horizontal shift, which was 6, and then I plugged it all into the function, and then I found the domain and the range. So that's how I found all my points, and then just substituted them, and then found all my keys to help me determine my function. So next I'm going to find the segment CD, which is going to be a square root. So that's going to be a square root function. So I'm going to be solving that over here. So for segment CD, it's going to be a square root. Okay. So we also have the form given for this, which is y equals to a x, so in a square root, x minus 12 plus 16. So this one, I'm going to first look at the graph. Actually, I'm going to first write down the form. So y equals to a square root x minus 12 in a bracket, and then plus 16. Okay, so next, I'm going to find my points and write them down. So if I look at the graph over here, so the graph, for the C, the points are 12, 16. So C, I have 12, 16. And then C to D, I have, for D, it is 20 and 12. So D is 20 and 12. So after I find the points, first I check that C fits the form or not. So if x equals to 12, I'm going to be first labeling them. So that's my x and that's my y. So for C, first I'm going to check whether or not it lies, whether or not the C fits the form or not. How I'm going to do that is that I'm going to just substitute these values into the equation. Okay, and then, so how I'm going to do that is that first I'm just going to substitute that in. So y is 16. So that's going to be I'm just going to check the x. So that's y equals to a 12. So I'm going to be solving that over here. So for the segment CD, it's the square root. So I'm going to write down first the square root function, which was given, and that is x minus 12 and plus 16. So from the graph, I know that the C starts at 12, 16. So I'm going to just write down the points, 12, 16, and D, and it ends at D, so that is 20, 12. So D is 20, 12. Okay, so first I check whether or not that the C fits the form or not. So how I'm going to check that is that I'm going to substitute the x value from the C, which is 12, into this function right here. So first I'm going to label them. I'm going to label this one. Okay, so that's going to be y equals to a and then 12 minus 12, substitute it, plus 16. So that's going to be 1. So y equals to a 1 plus 16. And then, no, that's going to be 0, actually. So 0 plus 16. So I'm going to get square root and all. So that is, so that is 16. Okay, so, which is good. So that means it does lie. So now I use the point D to find A. So that means I'm going to find D. So I'm going to just list the points again, which is 20 and 12. So now I'm just going to be substituting that in. So that's 12, A, 20 minus 12 plus 16. And then I just solve for that. So that is just 8 plus 16. And then I'm going to bring the 16 on the other side. So 12 minus 16 equals to a square root 8. So that's going to be negative 4 equals to a square root 8. Okay, so now that I have that, if I look at this square root and then the 8, so square root 8 is also the same as that. Okay, so it's the same as that. So now it's actually simplified to that. So I'm going to use that, and that's going to be negative 4 equals to a 2 square root 2. And then I'm just going to quickly just solve for this. So bring A over here, and then the 4 goes up here. So switch switch their spaces, because the A has to be on the left side just to make this easier. So that means this goes on the bottom, and then that's going to be, if I solve for that, simplified, that's 2, and then 2. So that 4 and that simplifies. So remove that, that's going to be 1, that's going to be 2, so 2. That's gone, that's just 1. So that means if I simplify this further, that's a negative. That's going to be negative square root 2. Okay. So now my equation is going to be y equals 2, and that is a. So a square root negative 2, and then x minus 12 plus 16. And I used that, and I got that from here. So I got that from this function I was given. So that is where I got that from. And I'm just quickly gonna find the domain and the range. Domain is going to be 12 x 20. If I look at this, so just how I solved for the other ones. So yeah, so it's going to be, if I look at the graph, 12 my x value, and then for D it's 20. So that's how I got that. So that's my domain. So my lowest and my highest x values, and then for my range it is going to be my minimum and maximum y values. So for this one it is going to be 12 and 16. So 12 y 16. So that's how I got my domain and the range, and that's how I solved for my segment CD. Okay, so that's how I solved for my segment CD, and so that's basically how I solve for all my segments. And yeah, thank you for watching.